Hello my dear students. In this video, we'll discuss class 11 mathematics chapter 4 principle of mathematical induction. Very important points, full concept and one basic example to revise your complete thing. First point is one key basis for mathematical thinking is deductive reasoning. It is reasoning are of two types: deductive reasoning, inductive reasoning. In deductive reasoning, we prove the theorems. By deductive reasoning, we prove theorems or proven statements. In contrast to deduction, induction meaning depends on working with different cases. We generalize the cases and develop a technique to prove that result, and the results generally are given in terms of n to prove by induction method, and develop a conjecture by observing incidences till we have observed each and every case. Okay, we generally use and work different cases. So in simple language, the word induction means generalized form of particular cases or facts. Second point, the principle of mathematical induction is a great way which can be used to prove a wide variety of mathematical induction. Each such statement is assumed as Pn. Now here concept start. Each such statement is assumed as P of n associated with positive integer n. Here n is positive integer, means natural number, for which the correctness for the case n equals to 1 is examined. Means for n equals to 1, we check the correctness of that statement which was given in the terms of n, where n is positive integer. Then assuming the truth of pk for some positive integer k, means we assume that it is true for p of k, means for n equals to k the statement is true assumed, and then we prove the truth of p of k plus 1 we establish or we prove based on pk and this p1. Okay, so how we prove the mathematical statements given in terms of n by the principle of mathematical induction. We have discussed the statement means first we assume the statement as Pn involving natural number n, where n is natural number or positive integer. First thing, the basic step, the statement is true for n equals to 1, means P1 we check. If it is true, means this is our basic step to solve this. This is the first step that you have to do in your exam. The statement is true for n equals to 1, and second step is called inductive step. If the statement is true for n equals to k, where k is some positive integer, here we assume that this is true for n equals to k, then the statement is also true for n equals to k plus 1. This we prove, we establish by using n equals to k. Now if statement is true for n equals to k plus 1, means truth of pk implies the truth of pk plus 1. Okay, means Pn is true for all natural numbers n. Here we have proved for n equals to 1. Here we have assumed that it is true for n equals to k, and we have proved that it is true for n equals to k plus 1. What it means, how we can say this true for all natural numbers n? Here n equals to 1. Okay, now n equals to k, let k is 1, so this n equals to k plus 1 means 2 na. So if you have proved for 1, it is true for 2, so now it becomes 2. So if n is 2, then it becomes 3. If n is 3, it becomes 4. So that way it goes up to infinite, means it is true for all natural numbers. Now we'll see basic example that will be clear for you. Let's say the statement is given 1 plus 3 plus 5 plus 7 plus dot plus 2n minus 1, that is equals to n square. If we have to prove this, what we'll do, first we assume this as Pn. So we'll write Pn is 1 plus 3 plus 5 plus 7 plus dot plus 2n minus 1 equals to n square. This complete statement with equal, this is called a statement, okay, in terms of n. Now we have to prove it is for all n, means all natural numbers. So first basic step is we are checking for 1. So for 1 means it is 2 into 1 minus 1 means 1. So for one term only, so one term is only 1. So left side only 1, right side it's 1 square means again 1. So 1 equals to 1 square. 1 square is also 1. So this P1 is true. Now we have checked, we have examined that P1 is true. Next step, we suppose that Pk is true for some positive integer k. So we have to prove that P of k plus 1 is true based on Pk is true. Okay, since Pk is true, what we have? We just put n equals to k. There it was 1 plus 3 plus 5 plus 7. Here 2n minus 1 equals to n square. That way, here we have put n equals to k. So 2k minus 1 equals to k square. This complete statement. This is first equation. Now this we have assumed that it is true because it is P of k. Now consider this. Now we have to prove this for k plus 1. So just put k plus 1 here, or 1 plus 3 plus 5 plus 7 plus 2k minus 1. Okay, for k plus 1 means up to k plus 1 terms. So now plus 2k minus 1, but here k is k plus 1. So 2k plus 1 minus 1. Okay, now this result we have assumed it is true, means this is k square. So this is k square and plus this is what? 2k plus 2 minus 1 means 2k plus 1. So k square plus 2k plus 1 is nothing but k plus 1 whole square. K plus 1 whole square, and here we assume this statement true for n equals to k, and here we are getting for n k plus 1 as k square. So here k plus 1 square means p k plus 1 is true, and then inductive proof is now completed. Hence we can say Pn is true for all natural numbers n by principle of mathematical induction. I hope it is clear to you. So just like and share our videos and subscribe my channel to get such types of videos. Thanks for watching.